In this example, let's find gradient vector, and then we will use it to find a tangent line to the level curve at the point. The function is given as x squared plus 9y squared. So we're first going to start with the gradient, of course. The gradient is a collection of all partial derivatives. In this case, there are two of them. Derivative with respect to x and derivative with respect to y. X squared gives you 2x, 9y squared gives you 0. With respect to y, x squared gives you 0, and then 9y squared gives you 18y. Now, we are asked to plug points 10 and 2. For your convenience, maybe sign them like so. Then, at the point 10 and 2, where 10 is x, the gradient first component will be 20. And then the gradient second component will be 36. 18 times 2, 36. So the gradient here is going to be 2x, 18y. And then at the point, it is 20 and 36. Reminding you, this bar and the point, it's international notation, which we can say out loud as the derivative at and then the given point. The tangent line slope. Let's figure out what to do with the tangent. I will first probably say, before we move to tangent, the goal is to create the equation of the line. Let's see. The equation of the line to the level curve. Z equals, this is my Z, 136. So we know equation of the line is y minus y sub 0 slope m x minus x sub 0. And we just recently learned that the slope can be found in so many different ways. The common mistake is to assume that 20 and 36 will be my slope here. That is not true. Or 20 over 36. That is also not true. So when you found gradient, we just learned that the gradient actually is perpendicular. So it's not tangent to the surface. It's perpendicular to the surface. So now we're using it instead of n. If you remember from previous notes, watch my other videos to review that. So gradient f is not tangent to the surface. But we can use it to find tangent. If you think that tangent line is perpendicular to the gradient, then you can use the idea that tangent line slope can be found from the idea of negative reciprocal of the gradient we found. So in this case, slope of the tangent line m will be, take the second coordinate. First of all, negative reciprocal means negative. Take the 36. Take the 20 and divide by 36. 20 over 36. Because the tangent line will have a slope, tangent line has slope minus 36 and 20, like so. Minus 36 and 20. Because. So we're going to use this idea instead. There are different ways to explain it, and in this case I will say either you multiply your corresponding slope for y over here, which is going to be exactly this, minus 36 or plus 36, whatever, whenever you want to put negative sign, and then 20 is over here, so maybe like so. Or you multiply everything by 36, and that's why the slope becomes exactly as you see it right now, minus 20 over 36. So the answer will be, we have the equation in front of us, and the answer will be y minus 2, where the 2 came from, that's the point. X sub 0 and y sub 0 were given. Y minus 2 equals minus 20 over 36. X minus 10. That is the final answer. Let me zoom in. And let me simplify. Y equals minus 20 over 36x plus 200 over 36 and plus 2. Create the common denominator. Simplify. And you will get this. I'll just write down instead of everything. 10x minus 18y equals 136. This is the equation you will get if you multiply everything by 36. Multiply everything by 36. You'll have 36y minus 72 equals minus 20x plus 200. Collect the coefficients and then divide everything by 2. So you will get this number on the right hand side, and then instead of 20x you will have 10x, and instead of 36y you will have 18y with a negative in front. That is a nice example of how to find the gradient vector, how to use the gradient vector to find a tangent line to the level curve at the given point.